Okay, so today we're looking at powers and multiplication of complex numbers, and we just started talking about this. Yesterday we looked at I squared is -1, and we just broke I cubed into I squared times I, so it's -1 times I, which is -I. Okay, how would you guys like to break up I to the 4th so we can figure out what it is? I squared times I squared? I like it. I squared times I squared. Well, I squared is -1. So it's like -1 times -1, which is +1. That's right. Okay. How would you like to break up I to the 5th? Lots of I to the 1st times I to the 4th. Okay. I to the 1st times I to the 4th. Well, I to the 4th is 1. So it's I times 1, which is just I. Okay? All right, how would you guys like to break up I to the 6th? You want to do 3 and 3? Sure. Okay, so I cubed times I cubed. Okay, I cubed was -I. So it's -I times -I, which is +I squared. What is I squared? -1. All right, so let's take a look at what we've done so far. So we said I to the 1st is I squared is -1, I cubed is I to the 4th is 1, I to the 5th is I to the 6th is -1. What do you think? There's a pattern. What would I to the 7th be? Okay, we have some conflicting answers, so let's break it up. How about I to the 4th times I to the 3rd? I to the 4th is 1. I to the 3rd is -I. So it's -I. So it's I, -1, -I, 1. I, -1, -I, 1. I, -1, excuse me, -I, 1. And it keeps going forever and ever. Yes, it does. Okay, now I can't claim this. Miss Fuller came up with this. It's a mnemonic that helps us remember this pattern. So our pattern is I to the 1st is I squared is -1, I cubed is I to the 4th is 1. So this helps us remember. Okay, so I go off today and buy a lotto ticket, which I don't do, but let's say I did. And then my numbers are pulled.
What?
So tonight you'll hear me screaming from Sonoy, I won! I won! See, I, the number 1, I, the number 1, I won, I won. That helps us remember the pattern. And the middles are negative.
I'm negative. I did.
Okay. All right. So if I just ask you I to the 13th, you're good. What is it? It's I, because we started the pattern over. If I ask you I to the 14th, you're good. What is it? -1. Okay. I to the 43rd.
Ooh, wait a second. That is. No, wait, hang on. Hear me out. -I.
Very good.
I guess.
That was an excellent guess. We know it goes through this pattern. And the pattern has how many numbers in it?
Every number.
4. It repeats every 4. So what we do, because this pattern repeats every 4, is we look at the number 43. How many times would it go through the pattern completely? 10. 43 divided by 4 goes in there do, we would write it out like this. We would say 43 divided by 4, it goes in there 10 times, and the remainder is 3. The remainder, that's what we want to know. Because this 10 tells us how many times it goes completely through the pattern. That's not so helpful. But the remainder is very helpful. So this is the same thing as I to the third, because that's my remainder, which is negative I. Awesome. Okay? Let's try another fun one. You ready? I to the 37.
Negative 1.
That. It's just.
I.
No, it's negative 1.
No,
No, it's I.
It is I. Okay, so if we take 37 and divide, 37 and divide it by 4, it goes in there 9 times, but we don't care about how many times it goes completely through the pattern. We care about the remainder part. So this is the same as I to the first, which is just I. Okay, let's do another one. I to the 216th power.
That's tricky. But it's not tricky. Really, all you have to do is.
Obviously, it's 1. Because get 1. No, it's not. No, it's
Oh, it's
wait,
24.
it's I.
24.
Okay, so 216 divided by 4. It goes in there how many times?
24.
50.
You're so confident.
4. 4. 54. But there's no remainder. So when it has a remainder of 0, that just means it goes completely through the pattern. What's the end of the pattern?
Nothing. Just I. There's nothing.
It's like 0.
Just 1.
It goes completely through the pattern. The end of the pattern, 1. Or if we think about this, the remainder being the power, any number raised to the 0 power is what? 1. So you can think of it either way. All right, so that's powers of I.
I like it.
Now, most of the time we'll be dealing with the smaller powers, but we'll throw in a big one every once in a while. Okay, so we only have 3 examples today, and then you get your work, and you'll have the rest of class. Okay, so what we're doing here is multiplying. The first one is a imaginary number times a complex number. The second one is a complex number times a complex number. And the third one, we are expanding or squaring that complex number. But all of this is multiplying. So if you want to take a second and write down those 3 examples across, we'll do them together in just a minute.
2I squared. We're doing it together. Oh. Then I'm sorry. It's alright.
Okay, I really think you guys know what to do without me even telling you. So you tell me, what do we do on number 1? Distribute. That's exactly what we do. We're going to distribute 2I through here. And so when we distribute, we get 6I minus 2I squared. So we need to know that I squared is negative 1. And what happens when we multiply by negative 1? It just changes the sign.
But wouldn't it be 2 plus 6?
It is. Because we're going to always write our answers in standard form, which for a complex number is the real part first, the imaginary part second. So it's 2 plus 6I is my answer.
I'm confused why we would change the sign.
Okay, because I squared is like multiplying by
Negative.
negative 1.
Oh.
it changes that from a -2 to a positive.
Okay.
Alright, number 2. It's a complex number times a complex number, but it's still distributing. So we're going to distribute the 5 through, and then we'll come back and distribute the -I through. So 5 times 2 is 10. 5 times 4i, 20i. Now let's distribute the second term here. -I times 2, -2i. -I times 4, -4i squared. Okay, so we are going to change because this I squared is like multiplying by -1. It becomes a positive. So when we add our real part with our real part, we get 14. And the imaginary with the imaginary, positive 18i. Alright, now this one. Did your teachers teach you that when you square a binomial, you square the first, you double the product, and you square the last? Okay, Sammy's teacher did. Alright. Or we could do what? Write it out twice and distribute it. Okay, so you try.
Can we go over the song? No.
It's not really a song, it's more of a chant.
Okay.
Square the first, double the product, square the last.
Hey.
Hey!
Oh, what? That's what I read.
He remembered the hay. Which tells me it wasn't very effective.
Wait, no, it should be. Did you do the same thing
You do. You do exactly the same thing we did on number 2. -16 minus 30i is correct. Okay, if you have 34 instead of -16, check your 25 and see if you change the sign with the I squared. Okay, so the front of this worksheet is your homework, just the front. The back is tomorrow night's homework, but I will save the paper.
You gotta get both of them to your choosers. Well, you don't know how to divide yet.
If you'd like to, you know, check, work ahead and go on Khan Academy and learn how to divide complex numbers on your own tonight, sure. All right, number 30. There is a typo. It should be -7x or -7x instead of 9. It doesn't factor if it's 9. It does if it's 7.
So instead of 9, it's okay.
It should be a 7 on number 30. So everybody make that correction. All right, you have the rest of the class to work. Ask me questions as you go. I'm going to cut off the recording now.